So let's take a look at this example here. So it says the particle A is moving along a straight line such that its displacement from a point P after t seconds is given by, right, and then we have the displacement function. And our domain is 0 to 25, right, inclusive for t. All right. So let's take a look at question A. Find the initial displacement of particle A from P. So initial displacement, right? So anytime you hear the word initial, I want you to think the time is equal to 0. Okay, so basically in part A here, we're trying to find, well, when is the time 0? So you can just plug 0 in here for t and work it out, or you can graph the function, right, and then use the table. So I've already graphed a function here, right? So if I just go to the table, control T, if I go to when 0, I get 15. Okay, so if I want to get out of the table, just click control T again. So right here, we know that this is equal to 15. Okay, so right here, basically when the time is 0, all right, we know the displacement is 15, in this case, centimeters, because they tell us in the question here. So 15 centimeters to the right of, all right, the object. All right, so basically, let's make sure we understand what's going on. So the particle A, right, this means that particle A is 15 centimeters to the right of point P. So the whole idea of displacement is, so when the time is 0, right, so let's say here's point P. When the time is 0, right, particle A, right, so when the time is 0, particle A is 15 centimeters, right, so it's 15 centimeters to the right. So how do I know it's to the right of point P? Because it's positive, right? If it was negative, it would be to the left of point P. Okay, so basically when you're reading this graph here, what's happening is as time starts, you notice that, so right here we have particle A, right? It's starting right here. Particle A starts getting closer and closer and closer to point P. So right here, when the displacement is 0, right? So right here, when the displacement is 0, that means that particle A and point P are in the exact same spot, right? When A and P are in the same spot, right, that means displacement is 0. So that means that point P is right here. Okay, so this is important to understand for this question. Okay, how to interpret the information and understand what's happening to the particle, right, compared to the fixed point. Okay, let's take a look at part B now. Let's answer part B. So part B, it says find the value of t when A first reaches point P. So A first reaches point P at this spot right here. So looking at our graph, that's this x-intercept. So the time for that, all right, so the time is approximately 2.47 seconds. Okay, so once again, when the time is 0, A is 15 centimeters to the right of P, and then when the time starts, A starts getting closer. So when the time starts, what happens is A is getting closer to P, so it starts heading towards P. So at 2.47 seconds, when the time is 2.47 seconds, A and P are in the exact same spot, right? Because the displacement right here is 0. Okay, so that's important to understand the context of that there. C, find the value of t when particle A first changes direction. Okay, so when you're looking at a displacement graph, right? So for displacement, the particle changes direction, all right, whenever there's a maximum or a minimum. That's where it changes direction, right? If you're looking at a displacement graph, okay? So in this case here, so we're looking at right here, we've got a change in direction at this minimum here and another change in direction at this maximum. All right, and they want to know, find the value of t when particle A first changes direction. So it first changes direction at this minimum. All right, so the time there is approximately 4.077 seconds. All right. All right, so let's take a look at part D. All right, so part D says find the total distance traveled by particle A in the first 3 seconds. So this means the total distance traveled we want to find right here. So we have the displacement function, so the absolute value of s of 3 minus where it started, which is s of 0, right? This is going to give you, all right, the total distance traveled. So we can just get this from the table. So s of 3, go to the graph. Here's our table. When x is 3, we get negative 2.6963. So we have the absolute value negative 2.6963 minus, and s of 0 we know was 15. So the absolute value of this is going to be approximately, so negative 17, so absolute value, that will become a positive 17.6963, and then we have centimeters. Okay.